All right, welcome back. What we're going to do in this video is build a spreadsheet that evaluates um, expected cost of accidents and probabilities based on age. We're going to do a pretty simple one here. The first thing we're going to do is calculate what the parameter is, in other words, the proportion. I'm going to look for the 25th percentile. So just what this means is a quarter of the population. Just like the median represents the 50th percentile, it's the middle observation. 50% of the observations are on one side and 50% on the other. The 25th percentile means 25% are below and 75% are above. Okay? So that's the percentile. I'm going to go ahead and clear these guys so again it's just a little bit easier to see what we're doing. You can always look up here. So for the percentile, there's a function in Excel that's going to give us what we're interested in. So equals and then percentile. Now there's two equations, percentile.x and percentile.inc. Inc means you're including the variable or the observations that are at the median or at the percentile level that you're interested in, and this one exclude means you're excluding those. So we'll show you what that means here in just a second. We're going to use the inclusive one, so I'll just click on that. Now I need my array, that's the data. So I'm going to come over to my data acquisition, and I'm interested in the age bracket, so I'll just click here, Control Shift down to highlight everybody, and now we'll enter a comma. And the next thing we want is our percentile. So we wanted the 25th percentile, so just 0.25. And then I'll go ahead and hit return. So what this is saying is that the 25th percentile of my distribution, the age is 25. Okay. Now I'm going to go ahead and do a count as well. So the count, we're going to use a function called countif. And there's multiple ways to do counts. We'll just start with a countif. So again, we're going to look at a range which represents our age. And come back to my data acquisition. So we're going to do our age range again. So I'll click here and then Control Shift and down. And then we want it to be greater than or equal to our critical age of 25, which we got from the previous one. And we'll go ahead and finish that. So in this case, I've got 9,730 that are above the 25th percentile. Or I could have gone less than or equal to. Now let me show you this inclusive aspect of it. So what this says is that we're just going to include everybody that's at the age of 25 in the calculation because it's inclusive. If I go exclusive, then we're not going to include the people that are at that age. And what we're talking about here is our proportion is not going to come out exactly what we're looking for because there's more people at the age of 25 that represent accidents. So our proportion is going to be just a little bit off for what we're interested in. So in terms of calculating our proportion, this is going to be equal to our count, and then we're going to divide that by the total number of observations in our sample. So we go back to our descriptive statistics tab. We're interested in age, so I'm just going to pick the age count here. And this is again kind of standard. I mean, the count is the same on every one of them, but we want to, if I'm talking about age, we want to use the count on the age population. It's just good technique. So we went to 25th percentile, which is 0.25, and we're ending up with a natural proportion of 0.76. All right, and that's because the sample is not perfectly set up. And I'm going to just go ahead and change this back to inclusive, which means the people at the age of 25 are included, and that's because our count if is going to be driven based on the underlying age. And we can actually make this a variable. In fact, we want to do that. So this is, we put a double quote and then an ampersand, which says to concatenate, and then we'll just pick our underlying cell. Okay, so now at this point, if I change my proportion, I'm going to say 0.35. It's going to update everybody automatically. All right. So this is again how to reference my in quotes is greater than, less than, greater than, equal to, whatever I want to do, and then we concatenate this underlying variable with it. So I'll go back to my 0.25, which we're setting up on. Now the proportion I want to talk about for a little bit. The problem here is because I'm using a sample. Even a really big sample, you can see that I'm not coming out with the exact proportion that I'm interested in. And that's kind of not what we want. Because I'm using a sample, I can't get the proportion. If my sample size increases to millions of observations, or if you think about the number of car accidents that are in the United States, it might be in the hundreds of millions over a 4 or 5 year sample period. This proportion is actually going to go directly to 0.75 in the limit. So we're just going to enter our actual proportion that we're interested in, 0.75. So rather than using the proportion of our sample, what we want to do is use the actual number that we're interested in, because in the limit, this is going to be correct. And in the limit, this is going to give us not the question that we're asking. All right, so with millions of observations, our 25th percentile is probably still going to be 25, or close to 25, 25 in a fraction of a year, if there's fractions of a year in the database, which it probably isn't. We're probably going to come up with 25. Maybe it'll be 26, but we're just going to use 0.75, because that's really what the question's being asked. For the 25th percentile, what's the expected cost? So the next thing we want to do, now that we have the proportion or trigger that we're interested in being 25, we want to calculate our conditional means. So this is going to be our average if, and then we're going to select our range for the criteria, which is our age. Back up here to the top. Click on our age again, Control Shift and down. And then we want to enter our criteria, so that's going to be, we want it to be greater than or equal to, and then quote, ampersand, and then we're going to pick our value here. So that's going to concatenate everybody together. And then finally, we're going to pick the column that we want to actually average, conditional average on. We'll pick the first one, Control Shift down, and then end it. All right, so if we're over 25, the expected cost is going to be $3,235. So if we're under 25, and what I'm going to do here, so I don't have to necessarily, well, I'll just retype it. What I could do is just lock these guys in and then change this, move it down, but we'll just redo it. Average. Remember, if I'm not putting dollar signs in, you shouldn't put dollar signs in either. But if you decide to, from a grade code standpoint, it may be an issue. Then again, we're just going to pick our age, Control Shift down, and then our criteria. So in this case, we want less than, double quotes, less than double quotes, our ampersand, and we'll come back to our binomial age and take 25. And then the next thing is we just do our data for the cost of an accident. We'll just click here, Control Shift up. That's really not going to work as well. Control Shift down and end our value. Okay, so we can see here that if you're older than 25, your expected cost of the accident is less than if you're under 25. So 25 and over, we're at 3,200. If you're strictly under 25, we're at 3,473. And this is a real number in the sense that if you want to go and rent a car, most rental agencies will not rent you a car unless you're at least 25 years old. Why is that the case? Well, because if you're under 25, the expected cost of an accident is higher, which means the insurance cost is higher, and therefore that rental company is less competitive than another one that was doesn't rent to people that are under the age of 25. Since it's a competitive market, they've all come to the conclusion that they want to be below that value. So I'm going to end the video here, and then we're going to come back and go ahead and complete or rough in the rest of it. From this point on, it's almost identical to setting up the other binomial distributions. All right, thank you. Bye.